So I'm going to start with problem 2. Problem 1 has more MATLAB stuff involved, so I can do everything with problem 2 right from the beginning. So I'm going to do 2, and then I'm going to do 1, and we'll go from there. So let's start problem 2. Problem 2, we are given x sub t, b sub k, sample frequency, and for the first part of A, we want to find x sub w hat. So the very first thing that I'm going to do is I need to change all of my cosines to positive cosines. If it's a sine, it needs to be a positive cosine. If it's a negative cosine, it needs to be a positive cosine. To do that, let me write down here, I have x sub t equals 5. So I'm going to change this plus 2 cosine of 500 pi t minus pi. Then I have to add a pi to change it to a positive pi. And then I have a 5 cosine 1750 pi t minus pi over 2 plus pi. So I'm just going to clean this up. I'm going to do x sub t equals 5 plus 2 cosine, and now these two will cancel out, and these two will just turn into a positive pi over 2. So let me clean that up just one bit. So then we have, just 500 pi t plus 5 cosine 1750 pi t plus pi over 2. Now what I need to do is I need to change this into x sub n. To change this into x sub n, what I need to do is I need to divide each of these here by my sample frequency. So in this case, it's 1,000. So I'm going to divide by 1,000, divide by 1,000. Easy way to look at this is these cancel out. Oh, sorry, not that part. Well, I'll do that one. These two cancel out, and I'm left with 5 over 10. And then these cancel out. So for me to go to x sub n equals 5 plus 2 cosine of 10 divided by 5 is a half, so pi divided by 2 n plus 5 cosine. This ends up being 7 pi divided by 4 n plus pi divided by 2. Now, when I convert to x w hat, what I'm concerned about is just the amplitude and the phase. And I'll show you what I mean by that. So, I'm going to write this out. X sub w hat equals, I'm going to start with this one here. So my amplitude is 5, and I have no phase, so it's e to the j 0, and this is when w hat equals 0. So for that one. Plus, now let's move on to this one. I have 2 e, and you notice over here there is no phase shift, so I'm going to have j to the 0. And this is when w hat equals pi divided by 2. Plus, and then we'll use, I don't know, we'll use red. My phase is 5. And my amplitude is 5, magnitude. And my phase is pi divided by 2. So I'm going to have e to the j pi divided by 2. And this is when w hat equals 7 pi divided by 4. And so that's from here. This one is from there. And this one, there's nothing there. So this is how you do part A. Now, when you look at part B, well, what does part B say? B says I need to find H sub W hat. Well, how do I go about that? Well, if we look up a little bit higher, we were given our our B sub K. So I'm going to take my B sub K's. So let me just erase this really quickly and clean it up. So my B sub K equals, we had a 4, a negative 7, and a 4. And because something was written there, we start at n equals 0, and this will be n equals 1, and this will be n equals 2. So we can write this as 4e to the j 0. And I just put a negative sign because it's always mean negative. Minus 7e to the negative j, and I take my n, which is 1 w hat. Let me add a w hat here. Plus 4e to the negative j w hat, and then I have a 2. Okay. Now what I need to look at is, what does any of them share the same amplitude in common? Well, this one and this one share the same amplitude. So what I'm going to do is I'm going to pull out that 4. So I'm going to have 4 times e to the negative j 0 w hat plus 4e to the negative j 2 w hat minus 7e to the negative j w hat. I got rid of the 1. I mean, you can leave the 1 if you want. We don't need to keep the 1 because 1 times anything is just itself. Okay. Now what I need to look at are these two here. So I have negative 2 w hat, and then I have 0 w hat. What is in the center of those two? In the center is negative 1 w hat. So what I'm going to do is I'm going to pull out a 4e to the negative j w hat. What this does is, now for this one up here, I'm going to have e to the j w hat plus, sorry, this needs to go away. I didn't catch this. I pulled a 4 out of here, so I don't have it anymore. Plus e to the negative j w hat minus 7e to the negative j w hat. So, if you remember, from over here, the cosine of theta equals to e to the j theta plus e to the negative j theta divided by 2. Well, that looks very similar to what we have over here. But I'm missing that divided by 2. So let me go ahead and erase this really quickly. We need to multiply this one by 2 divided by 2. So I'm going to get 8e to the negative j w hat times e to the j w hat plus e to the negative j w hat divided by 2 minus 7e to the negative j w hat. Let me put my hats on these. Okay, now I can convert this portion right here to a cosine. So I'm going to have 8 cosine of w hat e to the negative j w hat minus 7e to the negative j w hat. And this is our h sub w hat. So this is how you do part B. Now, part C, or well, it should be C. Part C, I'm going to call it C, says let's find y sub w hat. Okay, so let's go down a bit. I'm going to bring back down my, let me explain first. Y sub w hat equals x sub w hat times h sub w hat at a given w hat. So, let's go up here real quickly. Up here, when we saw that w hat, sorry, I clicked it to, 1 second. Dang it. 1 minute. I accidentally clicked it to erase. There we go. Sorry. So here, this one is when w hat equals 0. So what this is going to look like is we're going to have a y sub w hat equals some x sub w hat when w hat equals 0 times h sub w hat when that equals 0 plus an x sub w hat when that equals, I believe we had a pi over 2. Let me double check. Yes, pi over 2. Pi over 2 times my h sub w hat equals pi divided by 2. And then we're going to have the other one, which was 7 pi divided by 4. So I'm going to go ahead and erase this here, just kind of clean this up so I have a little more room. Give me 1 second. Okay. Let's start off with my y sub w hat when w hat equals 0. So let's go back up to the top, and what did we have? We had 5e to the j 0. So write that down. Equals 5e to the j 0 times, now everywhere you see a w hat in this h sub w hat, you're going to replace it with 0. So I have 8 cosine of 0 e to the negative j 0 minus 7 e to the negative j 0. Well, the cosine of 0 is 1. If you look at the unit circle here, at 0, cosine equals 1. So it's going to fill that in. So equals 5e to the j 0, 8 times 1, just 8, e to the j 0 minus 7 e to the j 0. Now, e to the power of 0 equals 1. So I'm just going to cross these out. Let's go back 1 second. Okay, so now I have 5. So I want black. There we go. 5 times 8 minus 7. Well, 8 minus 7 is just 1. So this equals 5. And remember, our phase was e to the j 0 because we have no phase. There's no e to the j something here. So I'm just going to box this really quickly. That's our first one. Now we need a y w hat equals pi divided by 2. So let's go back up and see what we had at pi divided by 2 was. Okay, so when, I'm going to take this green, when w hat was pi divided by 2, we had 2e j 0, or 2e to the power of j 0. So mark that down. 2e j 0. Now, everywhere in this other function, we saw a w hat, we're going to replace it with a pi divided by 2. So I'm going to have 8 cosine of pi divided by 2 e to the negative j pi divided by 2 minus 7e to the negative j pi divided by 2. Well, the cosine of pi divided by 2 is 0. And 0 multiplied by anything is 0, so this here is going to go away to 0. So I'm just going to rewrite this. So equals 2ej0 times negative 7 e to the power of negative j pi divided by 2. Okay, we multiply the amplitudes and we multiply the phases. So what I mean by this is I'm going to use blue for the amplitudes. We're going to get negative 14. Then I'm going to use green for this. So this is going to turn into e to the negative j pi divided by 2. What you can look at it is when you have e to the j0 times e to the negative j pi divided by 2, you're just adding these together. So this is our answer for yw hat equals pi divided by 2. I'm just going to circle that, or box that off. Alright, now we have our last one. We have y sub w hat equals, I believe it was 7 pi divided by 4. Let's go back up top and let's see what we had. Okay, I'm going to box this off in red. This is what we had at 7 pi divided by 4. Well, so I'm going to take that 5e to the power of j pi divided by 2, I'm going to bring that down. So we said 5e to the j pi divided by 2. Let me double check that. I just want to double check so we don't mess up. Yep, 5e to the j pi divided by 2. Now, what I'm going to do is that original function of h sub w hat, we need to fill in with 7 pi divided by 4. So, this is times 8 cosine of 7 pi divided by 4 e to the negative j 7 pi divided by 4 minus 7e to the negative j 7 pi divided by 4. Let's double check that really quickly. Sorry, I just want to double check my study formula. Yep. Okay. Now that we are here, what do we need to do? Well, the first thing we do is, what is the cosine of 7 pi divided by 4? That is over here. I'm going to draw my unit circle. Over here, that's pi divided by 4. Over here, 3 pi divided by 4. Over here is 5 pi divided by 4. And over here is 7 pi divided by 4. Well, the cosine of 7 pi divided by 4 is square root 2 divided by 2. And a positive, by the way. So I'm just going to rewrite that. 5e to the j pi divided by 2 times 8 square root 2 divided by 2 e to the negative j 7 pi divided by 4 minus 7e to the negative j 7 pi divided by 4. Well, these are going to cancel out, and this is left with 4. So let me write this one more time. 5e to the j pi divided by 2 times 4 root 2 e to the negative j 7 pi divided by 4 minus 7e to the negative j 7 pi divided by 4. I can combine the amplitudes of this one and this one by pulling out a e to the negative j 7 pi divided by 4. And what I mean by this is I am going to get 5 times 4 root 2 minus 7 e to the negative j 7 pi divided by 4. Sorry, let me have to erase this really quickly. I forgot my 5e to the j pi divided by 2. Now we can multiply. We are going to multiply the amplitudes first. So this amplitude is going to put in here. So I'm going to get, I'll write it in red, 20 root 2 minus 45. This is my amplitude. Times, and then I have e. What I'm going to do here is I'm going to multiply this one by 2 over 2 to get a common denominator. You'll see why it's important later. Sorry about a second. So I'm going to get j 2 pi divided by 4 times e to the negative j 7 pi divided by 4. Like I said, all we are doing is we are adding these together. So that equals negative j 5 pi divided by 4. So I'm going to go ahead and write that in black. So e to the negative j 5 pi divided by 4. And this is when y sub w hat equals 7 pi divided by 4. Now, this is kind of the answer. All these little things here are the answer. What I would like to show you next is there is a disconnect, I feel, from taking my w hats and putting them into y sub n. So let's do that really quickly. Let's find y sub n. Y sub n equals, I'm going to go back up to each of these. So, sorry, one second. Let me find out where I did that at. This one here, I have 5ej0. So, this one, I'm just going to have a 5 and leave that alone. It'll make sense about 2 seconds here. The next one, I have negative 14 e to the negative j pi over 2 when w hat is pi over 2. So, I'm going to have a negative 14 cosine. My w hat was pi over 2? Let me double check. I just want to double check one time. Yep. Pi divided by 2. N minus pi divided by 2, which was my phase. My next one, the 20 root 2 minus 45, it's just some value. You could I'm going to leave it as 20 root 2 minus 45. I'm just going to leave that alone. You could plug it into a calculator and find a value for it. I'm not going to do that. So I'm just going to put plus 20 root 2 minus 45 cosine. My w hat was 7 pi divided by 4n minus 5 pi divided by 4. And this is how you would find your y sub n. So this is how you do problem 2. And you just found all of your y sub w hats at each w hat point. You could then write it into the form of y sub w hat equals, and then you'd put each of the values there, and underneath it, I'll just mark y sub w hat equals 0, y sub w hat equals pi divided by 2, w hat equals 7 pi divided by 4. I like to write it like that, just so I know what each one is referencing. Now let's go to problem 1. Problem 1 it's much longer, so it's going to take a minute. So, the first thing we want to do is part A. Find h sub z in negative z polynomial form. Well, I'm going to show you a little tricky. E to the power of negative j w hat equals z to the power of negative 1. If we had a 2 here, this would be negative 2. If we had a 3, this would be negative 3, and so on and so forth. Just so, I'm going to skip ahead, because the first thing I like to do is to put h sub w hat into h sub z form. So let's go ahead and do that. So I'm going to have 1 minus e to the j 3 pi divided by 4 z to the negative 1 times 1 minus e to the negative j 3 pi divided by 4 z to the negative 1 1 plus e to the negative, I'm sorry, let me erase that really quickly. I thought that was a phase. Z to the negative 1, all divided. Now notice the first one over here is raised to the power of 2. So I'm just going to write it twice. So I'm going to have 1 minus 1 half z to the negative 1 times 1 minus 1 half z to the negative 1 1 minus 1 half e to the j pi divided by 4, I believe. Yep, pi divided by 4 z to the negative 1, and then 1 minus 1 half e to the negative j pi divided by 4 z to the negative 1. Now we can start distributing. I'm going to distribute the top one first. So I'm going to distribute, let me just mark off. I'm going to distribute for these two to FOIL. So we go back. First thing I'm going to do, distribute the 1 into there and into there. So this is going to be the same thing. 1 minus e to the negative j 3 pi divided by 4 z to the negative 1. We put our parentheses. Then I'm going to distribute this in to each of these. So go back. Okay. I have I'm on black, sorry. Negative e to the j 3 pi divided by 4 z to the negative 1. Then because these e to the j 3 pi over 4 and then e to the negative j 3 pi over 4, those are opposite, those are going to cancel out because remember, like I said, we're just adding what's up top. So when I add up top, those go away. So I'm going to get positive z to the negative 2. And then I'm just going to bring over 1 plus z to the power of negative 1. All divided. Then I'm going to group these two and then these two. Just so you know what I'm doing. Okay, first things first, let's do the first one. So I'm going to have 1 minus 1 half z to the negative 1 minus 1 half z to the negative 1 plus 1/4 z to the negative 2. Then do the next thing for the next one. 1 minus 1 half e negative j pi divided by 4 z to the negative 1. And do the same thing again. Minus 1 half e to the j pi divided by 4 z to the negative 1. And then I'm going to have plus 1/4. The e's go away. z to the negative 2. Okay, now that I have that, I'm actually going to erase what's up top just so it's cleaner and we're not getting confused with what's going on. I am just going to erase what's up here. Just so we understand what step we're on. I don't want there to be any kind of confusion as to what's going on of where I'm at. Okay. The next thing I want to do is, like I said, cosine of theta equals ej theta plus e to the negative j theta divided by 2. And when we look at these, this one and this one, I almost have that. I'm very close. So what I'm going to do is I'm going to pull out on this one here. I'm going to pull out a negative z to the power of negative 1. And if you're confused by that, you'll see by like 1 minute, you'll see exactly what I'm talking about. So I have 1 minus z to the negative 1 times, now because addition is commutative, you can swap around the order. That's all I'm going to do. So I'm going to have e to the 3 pi divided by 4, I forgot the j, plus e to the negative j 3 pi divided by 4, plus z to the negative 2, 1 plus z to the power of negative 1, all divided by, now the next thing I'm also going to do is I'm going to combine these. A 1/2 plus a 1/2 is a 1. So a negative 1/2 plus a negative 1/2 is just a negative 1. So I'm going to write that down here. So we got 1 minus z to the negative 1 plus 1/4 z to the power of negative 2. Now for this one down here, I'm going to pull out a negative 1/2 z to the negative 1. You'll see why. So 1 minus 1/2 z to the negative 1 times, like I said, I'm just switching the order of the e's because it's communicative is the correct word. That's addition. So pi divided by 4 plus e to the negative j pi divided by 4 plus 1/4 z to the negative 2. Okay, now what I can do is I can multiply, let me get a highlighter out. This portion here, that looks horrible. I don't know why it's so thin. Alright, I can, this one and this one, I'm going to go back and erase that, don't worry. I can multiply that by 2 over 2. So, if I get 1 minus 2 z to the negative 1, and I'm going to have, I'm just going to write it, then I'm going to erase it. I'm going to have e to the j 3 pi divided by 4 plus e to the negative j 3 pi divided by 4 all over 2. Well, this is the same thing. We're in the cosine form. So this is going to be the cosine of 3 pi divided by 4. So I'm just going to write that down. I'm going to get rid of all this. So I'm going to have, put a pen, the cosine of 3 pi divided by 4 plus z to the negative 2 times 1 plus z to the power of negative 1 all over 1 minus z to the power of negative 1 plus 1/4 z to the negative 2 times 1 minus, now I'm going to do the same exact thing. I'm not going to walk through the steps. It's a little redundant. But I'm going to end up getting z to the negative 1 cosine of pi divided by 4 plus 1/4 z to the negative 2. If you need help with that, just let me know. I'll walk through that again if you need me to. Just leave a comment, or most of you guys are going to be on Discord. Discord me, and then I'll walk through that one. Okay. Now all I'm going to do is I'm going to solve for my cosine 3 pi divided by 4 and my cosine of pi divided by 4. So I'm going to get 1 minus 2. Well, the cosine of 3 pi divided by 4 is negative root 2 divided by 2. Z to the negative 1 plus z to the power of negative 2. 1 plus z to the negative 1 all over 1 minus z to the negative 1 plus 1/4 z to the negative 2, 1 minus, well, the cosine of pi divided by 4 is root 2 over 2, so I'm just going to write that, root 2 over 2, z to the negative 1 plus 1/4 z to the negative 2. Okay, the next thing I'm going to do is this and this are going to cancel out, and these are going to turn to a positive, because negative and things are positive. So I'm just going to rewrite this one more time. I'm just going to walk you through it step by step, so there's just no confusion. 1 plus root 2 z to the power of negative 1 plus z to the negative 2. 1 plus z to the negative 1 divided by 1 minus z to the power of negative 1 plus 1/4 z to the negative 2, 1 minus root 2 divided by 2, z to the negative 1 plus 1/4 z to the negative 2. Okay, now we have to distribute these. So I'm kind of running out of room here. I'm going to distribute this, and then I think we're good. So let's see if I have enough room. First thing, I'm going to distribute the 1 in on top. So I'm going to have 1 plus z to the power of negative 1. Then I'm going to distribute this one in. So I'm going to have plus root 2 z to the power of negative 1 plus root 2 z to the power of negative 2, and then plus z to the negative 2 plus z to the negative 3. Then I'm going to do the bottom. The bottom we're going to have many more terms. So let's do the 1. So I'm going to have 1 minus root 2 divided by 2 z to the negative 1 plus 1/4 z to the negative 2. Then I'm going to do the negative z to the power of negative 1. So I have negative z, negative 1, plus root 2 divided by 2, z to the negative 2, minus 1/4 z to the negative 3, plus then I'm going to do the 1/4 one. So I'm going to have 1/4 z to the negative 2 minus root 2 divided by 8 z to the negative 3 plus 1/16 z to the negative 4. Okay, now I do need to combine my like terms. So I'm going to start at the top. So I have 1 plus root 2 z to the negative 1 plus 1 plus root 2 z to the negative 2 plus z to the negative 3 all divided by, and then combine my like terms again. So I have 1. I'm just going to underline it because there's many more. Z to the negative 1, Z to the negative 1, and that's it. So I'm going to have minus 1 plus root 2 over 2 Z to the negative 1. I know it was a negative sign. I just brought the negative sign out up front and then put the positives there. So if you're any confusion with that, let me know. Then I'm going to do blue for negative 2, negative 2, negative 2. Wait, for this, I need to change this one here into under 4. So what I'm going to do is I'm going to do 2/4. I hope that makes sense. So for that one, I'm going to have plus, this should be a 2 plus root 2, 2 root 2, divided by 4, Z to the negative 2. Then I have my 1/3. Again, this needs to turn into a 2. That needs to turn into an 8. So I'm going to have minus... one second, where am I at? Minus 2 plus root 2 divided by 8, Z to the power of negative 3, plus 1/16 Z to the power of negative 4. And this is how you do part A. I'm going to go ahead and erase all this so that I can show you how to do part B. Part B, I am not going to do this by hand. I am going to use MATLAB for this. If you have any issues with that, I don't care. I'm not going to go through and solve for this. So, the first thing we need to do is we need to find our poles. Sorry, I need to erase this. We need to find our poles and we need to find our zeros. To do that, what we need to do is turn this into a positive Z domain. So to do that, I take Z to the power 4 over Z to the power 4, because if you look down here, Z to the power of negative 4 is our greatest, or I guess our smallest if you want to look at it, power. So because of that, I'm going to multiply that Z to the power 4 in on the top and the bottom. So I'm just going to put it in right up here. So I'm going to have Z to the power of 4 plus 1 plus root 2, Z to the power of 3 plus 1 plus root 2, Z to the power of 2 plus Z, all divided by, now do the next one, Z to the power of 4 minus 1 plus root 2 divided by 2, Z to the power of 3 plus 2 plus 2 root 2 divided by 4, Z to the power of 2 minus 2 plus root 2 divided by 8, Z to the power of 1, I'm just going to leave that alone, plus 1/16. So we have this function here. Now, I'm going to show you how to do this in MATLAB. So, give me 1 second so I can change over to my mouse and keyboard, and we can go ahead and do this. So, the first thing that I'm going to do, I actually did this prior, so I'm going to go ahead and erase this all in here. So I'm going to call this my poly zeros, and I'm going to call this my poly poles. Okay. So my poly zeros, what I need to do is I need to take these coefficients up, oh, I'm sorry. I need to take these coefficients up front and put them into my matrices. So I'm going to have a 1 plus root 2, 1 plus root 2, 1, and I need to include that, I'm going to include that 0 as well, because there is, to the power 4, there should be 5, like there are down here. So let's go ahead and do that. So I'm going to have 1, comma, I need to go back and look, I'm sorry. 1 plus root 2, 1 plus the square root of 2, comma, 1 plus the square root of 2, comma, the other one was 1. Yep. Comma 0. Oh, 0. Now I do the same thing for my poles. So my poles are going to be what's down here. My zeros are going to be what's up here. So I'm going to have 1, and I'm going to have this negative. I can throw the negative in all of them, or just multiply the whole thing by a -1. I'm probably just going to multiply the whole thing by a -1, just so you know. So let's start off. So I have 1, comma, -1 times, well, what's inside of here? I have a 1 plus square root 2 divided by 2. 1 plus square root 2 divided by 2. Go on to my next one. I have a 2 plus 2 square root 2 divided by 2. I can pull that 2 out, and I'm going to have 1 plus square root 2 divided by 2. Oh, do you see how I did that? So I'm just going to go ahead and do that. So 1 plus square root 2 divided by 2. So, 1 plus square root 2. And now this whole thing is divided by 2. Then I have my next one, which is negative. So let's do a -1 times, what do we have here? We have 2 plus square root 2 all divided by 8. 2 plus square root 2, and then this whole thing is divided by 8. My next one, I have a 1 over 16. 1 divided by 16, and now I'm done. So I just plug this in, and so I do poly zeros, and then I do poly poles. Okay, then I run it. It gives me, yep, right here. These are my zeros, these are my poles, and I can write that down. Now, the question becomes, now we have question 3. Question 3 says, using the PES demo MATLAB program, check parts A and B, paste PES demo GUI on the next page. For this, what I'm going to guess is we're just going to, not guess, I'm just going to do this. Alright, so, I'm going to put semicolons, and I'm going to use PES. Let's run it. Oop, I need PES demo. Oh, you know what I didn't do? Give me 1 second. I need to add these to path. It does it every time. Let's see, right now. Boom, there we go. Okay. Wait for our GUI to pop. Alright, cool. So, for my poles, all I want to do is I'm just going to plug in my equation, or I can plug in my actual values. Doesn't quite matter. I think I'm just going to plug in my values. So, actually, no, I'm going to plug in my equation that I got. So, what do we get up top? I believe I'm just going to plug in all this up here. So, I have 1 minus, I don't think I can actually get this. let's just go ahead and plug in my actual values that I got from MATLAB. Let's go ahead and do that. Sorry. So let me scroll up to my zeros and poles so we can see them down here. Okay, for my poles, I have a pole at 0.3536 plus 0.3536, and then I have the conjugate of that, if you can see here. So what I'm going to do is I'm going to add it with the conjugate, and so I have 0.3536 comma 0.3536, and I'm going to add it, and see, it gave it my conjugate. Now I'm going to do the same thing here. You notice this is the same exact spot, so I'm not going to add with conjugate, and I'm going to get 0.5 comma 0. I'm going to add it, and add it here. Now I need to add my zeros. So for my zeros, I have 0, 0. So, and I don't have that twice, so I do not want to add it with the conjugate. So I'm going to add it not with conjugate, so I'm not going to click that. Not with conjugate, so I'm not going to click that. I have 0, comma 0. I'm going to add it, and it's not going to do anything because there's already a pole here. Now I'm going to do -1 plus 0, so -1, 0. And that does not have a conjugate, so I'm not going to add that. Even if I did, it wouldn't make a difference. So that's here. Then you do the next one. Negative. If you notice, these two are conjugates of each other. So make my life just a bit easier. I'm going to add with conjugate and do the first one. Negative 0.7071 comma 0.7071, and I'm going to add it, and so I have all my poles here. You can copy and paste this in, or you can just, print this off and then add it into your thing. This makes a quick difference. What I want to see is going to be me experimenting right now. You can click off the video now. I showed you how to do everything. I'm going to try to plug in my equation, and I'm going to see if that works. So you could stick around if you want. It's make a difference to me. So let's try it out. So I have 1 minus e to the j 3 pi divided by 4. So I have 1 minus exponent, and in my exponent I have, j 3 pi divided by 4 negative j 3 pi times j times 3 times pi divided by 4. Let's make sure. I want to double check this. I don't want to mess it up. Times, where we said this was z to the power of -1. I don't believe you just put pow. I forgot, sorry. Yeah, it's just the power of z to the power of -1. Close that off. I have this times. Well, let's just add it, see what happens. It does not like that. Alright, so my guess would be you would have to plug it in as, the actual values. I don't believe you can just plug it in. Yeah, thank you.